A top engine rebuild begins with removing the muffler. Loosening the radiators and moving them forward makes room for pipe removal from the engine cylinder head. Exhaust pipe nuts removed, the pipes can now be slid forward and pulled away from the engine. Protect the radiators when you remove the pipe. Drop the skid plate and drain the cooling system by removing this bolt from the water pump. Loosening the radiator cap will allow full flow of coolant. Coolant drained, remove the clutch cable. Move the clutch and other cables out of the way. Put hardware back in place where possible. Loosen the breather hose, then loosen the triangle brackets that support the upper end of the engine. There are 3 bolts with nuts. Remove the compression release cable and bracket. Again, tuck the cable and bracket up and away from the engine. Remove the 4 bolts that hold on the rocker covers and place these parts safely aside. If you're at top dead center on the compression stroke, the rockers should all be loose. Remove the rocker box 6mm bolts. Loosen them evenly. Keep track of bolts with copper sealing washers and make sure they get reinstalled in their proper locations. Remove the 2 8mm bolts last and rock the rocker box slightly to loosen the rocker box from the dowels. Remove the rocker box carefully and don't scratch the mating surfaces. Remove locating dowels. Now carefully remove the chain tensioner, loosening the bolts evenly. Make sure the tensioner slides out freely. You can now remove the camshaft sprocket. There are 2 bolts 180 degrees apart. Make sure you don't drop parts down into the crankcase. Rotate the crankshaft and the camshaft by turning the flywheel. Lift the sprocket out carefully as you remove the camshaft and bearing. Hold on to the bearing. I accidentally dropped it between the chain halves, which is not a problem. The bearing cannot fall into the crankcase from this position. I removed the dowel pin and the bearing with a magnet. Remove the retainer for the oil plunger and spring. Remove dowels and set pins and keep track of their locations. Support the chain, don't let it drop into the crankcase. I use a 6-point deep set impact socket to loosen the 4 14mm nuts. Loosen them uniformly, just a few turns at a time. This will eliminate the risk of warping the head or distorting it during removal. Keep track of the washers. Don't let any hardware fall into the crankcase. If necessary, remove the washers with a magnet or leave them in place and be careful when you remove the head. There are 4 cylinder and head hold down long studs, nuts, and washers. I use mechanics wire to hold the chain up. The wire is running upward to the handlebar cross brace. Keep track of all hardware. Lay it out so that it can go back together the same way it came apart. Now I gently tap the cylinder head upward with a plastic sand-filled hammer. Use extreme care not to damage the aluminum casting. Loosen the water elbow on the opposite side of the head and remove the carburetor and rubber intake manifold. Head loose from the dowels, chain in place. I lift the head upward. Clear the studs and use extreme caution not to damage the mating surface between the head and the cylinder as you lift the head out of position and away from the frame. Now you can detach the mechanics wire from the handlebar and slide the wire through the head. The head is free and we can see the excessive carbon buildup from valves that were not seating properly and compression was low. The Nickel can be carefully examined in the cylinder now, and the cylinder ridge shows glazing and damage from debris running through the upper cylinder and combustion chamber. Compression was obviously low in this engine. Now I loosen the bolts that hold the cylinder to the crankcase. I'll gently tap the cylinder upward using a sand-filled plastic hammer. Do not damage castings and make sure all hardware is loose. Lift the chain guide out of the cylinder. Raise the cylinder barrel carefully, making sure you protect the piston and connecting rod. Lift it straight up. Watch that I'm using the heel of my hand to gently set the piston down on the crankcase ledge. I'll now slide the chain and mechanics wire through the cylinder barrel. and place the chain carefully down on the side of the crankcase. Holding the cylinder barrel squarely, I gently pry the lower portion of the cylinder barrel through the two studs without damaging the studs or lower cylinder barrel. We can now examine the cylinder barrel. The nickel is intact in most areas of the wall, but up in the ridge area you can see the scoring damage and signs of abuse from debris running through the upper cylinder. This engine was running an extremely lean main jet. The heat in the cylinder is obvious, and the lower portion of the cylinder is showing skirt drag from the piston, although there's no sign of seizure on either the piston or the cylinder barrel, and that's a good thing. There's no damage to the engine beyond the upper cylinder wear and the valves, which show an excessive amount of carbon and are obviously leaking. This engine had proper lubrication and quality oil, and with liquid cooling, excessive damage did not occur from running the exceptionally lean jet. Spark plug thread damage that required the installation of the time cert was likely due to heat as well. Carbon buildup in the head and the skirt wear on the piston are indicative of an engine that was running too lean and lost valve seal. The cylinder head and barrel are now headed to LA Sleeve for reconditioning. A new piston will be installed during reassembly.